So here we present discovering regularities in enterprise datasets through deep learned natural language question answering framework. As we are aware that majority of people have their data stored in the form of CSVs. They often struggle dealing with it to get conditional results and visualizations. For instance, this guy's boss has given him the assignment to analyze the company's sales in each quarter by regions. He is a kind of lazy person and wondering whether he could have a system where he can use English sentences to do it without any manual intervention. Such tasks are difficult because data is complex and is generally present in multiple files. It's difficult to operate the tool for naive users. Generally it required the understanding of SQL or other database query language. Lot of effort required to get the desired output and then visualize and derive facts or outliers. Now we will discuss the framework which we have proposed to address this problem. We have a NL interface where we convert a natural language sentence to its equivalent database query and fetch output. Now, we take this output and derive some explanations or interesting facts. Finds outliers or exceptions. Visualize the data if required. Rationalize the dataset. To explain the whole architecture we split this into two parts. First we will discuss the NLQA framework. Then analyze the output using formal concept analysis. Going forward in NLQA, we have a two-step process. From natural language sentence, we predict the intermediate sketch which is basically the logical form representation. And then construct the database query like SQL, CQL, etc. Now, for example, there is a query, list people with more than 3 publications in AI. We take this query and pass this to a pipeline of sequence tagging models based by LSTMs with CRF layer. The deep learning models identifies the predicates, values, meta-types, aggregations and operators and outputs the intermediate sketch. This sketch is further passed to the query generator. We store the data in the form of Neo4j knowledge graph. Finally the DB query is generated and yields results. Next, we take this output and form its equivalent formal context. Using formal context, we construct the lattice and finds the implication rules with CONEXP tool. In this way, we can derive explanation and outliers. Now, let's have a look at demonstration. We would be showing the demo using a public dataset taken from IJCAI machine learning repository. This dataset is about the information of people like age, salary, occupation etc. by their country. We construct the Neo4j knowledge graph from the CSV, and finds the implication rules as well. This is the main interface of our system. On the right side is a chatbot which is a NL interface to the tool. And the complete data is displayed on the left side. Let's start with an example. How many people in each country? On the left side of window you can see the count of people grouped by their country. Based on the nature of the data, it also predicts the appropriate visualizations. Here is the bar chart. We can also click on the debug button to view the back-end processing. First the sketch is generated, then computed the shortest path between all the nodes. Finally CQL is constructed and fired. Let's take one more example. List all the people who are working more than 65 hours per week. You can see the output of the query on the left pane. There is the Analyze button which shows the lattice of the output. Such visualization of data helps in understanding the structure better. It also shows the outliers or exceptions in the dataset for this query. Here you can see that these are the rules extracted from lattice. On matching them with the implication rules computed earlier, we can derive to the following outliers. Adash is working more than 65 hours per week having bachelor's degree, but he still earns less than $50K. Similarly you can see other outliers as well. Now, let's have a look at transformations. There are two queries. First is, list all people belonging to Vietnam. And second is, list all people belonging to Cuba. Now, these two result set have different structures. Can we convert the Vietnam structure to somewhat like Cuba? We can see both the lattices here. To transform the Vietnam structure to Cuba, we need to remove the concepts in the left box, and introduce the concepts displayed on the right box. So at last we conclude that such approach of using pipeline of deep learning models to answer queries and then further analyze it using FCA is an effective solution to the users struggling with data. Thank you.